Alrighty, this is my advanced SSTO design. As opposed to my last SSTO design, which only included 2 turbojet engines and 1 rocket engine. This one has 4 turbojet engines and 2 rocket engines. These are a little bit different rocket engines as opposed to the LV, what were they? They were the 45, LVT 45. These are aerospike rockets, which are really efficient at sea level and outside the atmosphere, and it really doesn't matter once you're in the atmosphere. You're as efficient as you're going to get outside the atmosphere, but they're just a nice little engine to have. Very low profile. I'll show you guys later why they need to be low profile, because otherwise this craft would be really long, and I already have to land this craft pretty much straight. I really can't tilt it up at all. I can't land with the back wheels. All the wheels have to land at the same time. So let's look at some of the features that I've added to this one. This SSTO just has a basic Mark I cockpit, standard with the other one. It features the Mark II fuselage, which is a little bit bigger, and the appropriate adapters. And the Mark II fuselage is what feeds fuel into the turbojet engines via this pathway of fuel here, and there's a connector here too, somewhere. I think it's this one. Anyways, these jet engines are fueled by this system here that goes on the outside, and then this fuel set that's coming in like this, it fuels these tanks from outside in, inside to these tanks to the engines. So that's how that rocket fuel works. This is rocket fuel here, this is jet fuel right here. Though in Kerbal Space Program, liquid fuel from the rocket engines and the Mark II fuselage are interchangeable, and actually later I'll pump, to even out the spacecraft, I'll pump fuel into here, all the fuel into here, to balance it out once we overall. And so that's the basics of this craft. I have 16 ramjet engines to get us to an altitude of 20,000 meters before we have to cut the turbojets. And then I have an interesting design. Because these turbojet engines right here, I can't put stabilizer fins on the back, so I had to make this kind of X design, kind of like an X-wing fighter. So that's kind of cool. And the drone, which is the other big part of the spacecraft, the big drone on top, it's just a basic atmospheric drone. It has It has the basic atmospheric sensor array. It has a small probe body, very low profile. It has RCS for maneuvering in space, and some batteries, and then some solar panels. And also, my SSTO also has the big solar panels, and those will deploy once we get into the atmosphere. And the SSTO also has a space shuttle design to it. It has these liquid monopropellants, and on the nose here you'll notice a lot of monopropellant related, what are they? Thruster packs, yeah, the thruster packs. I have the linear ones for linear movement, and then I have the quad ones for other maneuvers, and moving forward and backwards mostly. And yeah, that's my basic SSTO design. As you can see, I use these swept wings. And the reason why there are these struts everywhere is Kerbal Space Program isn't really perfect in regards to that. Once you bolt everything down, it doesn't stay bolted down. There's a little bit of wobbling, and there still is a little bit of wobbling that I haven't been able to get rid of, mostly because it stems from these fuel tanks rocking up and down. But as long as we're not going excessive G's, we're not having excessive G forces, the craft should remain fine. It's to be expected that there's a little bit of wobbling and rocking, and the struts are just to make sure that everything is tied down in case it isn't. Anyways, let's fly this thing and see how she performs. Alright, so we're gonna just do a basic takeoff. I'm gonna start from the cockpit just for your viewing pleasure. We're gonna start rolling down the runway. It's kind of hard to accelerate this craft at first. It's kind of weighty, but once it gets going, I mean, the 4 turbojet engines, they really push, and they're really good at pushing really hard and fast. They have a lot of thrust to them. And you'll notice that when I took off, I really took off at a really shallow angle, and again, it's because my craft is so long, and that's the main reason why I chose those aerospike engines, because if I had conventional rocket engines, they would be really long, and I would basically just be waiting until I was until the end of the runway and just allowing the slope of the runway to let me take off. So those toroidal aerospikes are really good because they're just really low profile. Yeah, that's the basics of takeoff, and this is just a standard takeoff. It's going to be really boring. I'm going to try to entertain you for the next couple minutes as we just accelerate into the sky. I don't really have much to say. I mean, in my last video I explained pretty much all the science behind an SSTO. You just you go at a whatever angle you want. The shallower the angle, the better, though. I'm just for speed, so that we're not sitting here all day. I'll be traveling at a 90-degree angle, and the yellow circle with the 3 prongs sticking out of it, that's called apoapsis, and that is the top of your arc, so to speak. I'm just looking at the panels for your entertainment, and those panels are accurate. They're real panels, and they'll tell you everything. And there's a mode some Kerbal Space Program players like to play called manly mode, where all you can use is the cockpit, and it's really difficult, and I'm never going to do that, or not for a while, never say never, but anyways. And so your apoapsis is also your direction, so even though I'm pointed at greater than a 90-degree angle right now, the apoapsis marker is actually my trajectory. So my trajectory is at a 90-degree angle, but I'm actually pointed at greater than a 90-degree angle. That's just because of the lift of the craft, the weight, and the engines. It's a bunch of factors. So I'm not traveling. My craft is not really traveling at 91 or 92 degree angles. I'm actually traveling at less than 90 degrees. Or right now, I'm probably traveling at 90 degrees. And we're currently reaching above 10,000 meters, and I think, I can't remember, it's either 10% or 1%. At this altitude, oxygen is one of those two numbers. It's 10% than it is at sea level, or 1%. I'm going to go with 10%, that sounds a little better. But it may very well be 1%. But at this altitude, we actually, the engines, even though there's not as much atmosphere, we're traveling fast enough that the engines are still getting enough oxygen to power, and since there's not as much atmosphere, we can move much faster. We can push faster because there's not as much atmosphere pushing against us. And also, as I mentioned earlier, another reason why you want to travel at a shallower angle is because the shallower the angle you travel at, the more the Earth's gravity, or in this case Kerbin's gravity, works with you. And so you want to travel at a shallower angle, and these two things working together will get you into orbit. And so, right now I activated the engines, so the engines and the jet engines were working together for a while. Now I've turned the engines off, or I'm about to. Yeah, they're off right now. And the engines are turned off. Now I'm just working on jet engines, and I'm going to occasionally turn on the monopropellant, which is that misting stuff. It's, I think it's nitrogen, liquid nitrogen, or something like that. Maybe, I'm not entirely sure, but it's some sort of hypergologic liquid, very kind of gel-like, I guess. I'm not entirely sure, but it's this weird in-between solid and liquid state. Liquid. And that is used to stabilize the craft, and when the rocket engines are turned off, to maneuver the craft laterally and longitudinally, as well as vertically and horizontally, in all angles you can imagine. And yeah, that is the basics of the craft. We're going to start approaching altitude shortly and leveling out. I actually, because I use NVIDIA Shadowplay to record this, this was actually shot last. This was the last thing I shot, so you'll see on the map, you'll see some other launches. Those were, I guess you could consider them tests. Really, Shadowplay screwed up and deleted a bunch of my footage. I mean, it doesn't really matter. All the launches are pretty much the same. I I don't really vary with launches. In fact, I'm sure if I somehow got that footage and layered the footage and opacity, it'd probably match up pretty well, so you're not missing much. The landings are a little different, because landings are always a little complicated. And you'll see the landing in a little bit, but currently we're just getting up to altitude. Once we break about 70,000 meters, we're going to level out, because we just want to let the pull of the planet pull us, and that'll give us a lot more energy. And the more energy that we can pull from the planet that we don't have to use means more fuel later and more maneuvering. Though, I mean, this is a very basic mission, just to demonstrate what an advanced SSTO mission would be rather than just flying to orbit. And this would be one of them, launching a atmospheric satellite to observe the Earth, or for the military it'd be for a spy satellite of some sort. I'm going to accelerate to apoapsis. The other thing is, burning at apoapsis is the most efficient thing you can do if you want to increase your periapsis. And that's why I accelerated. So I'm going to start burning, and as you can see, it's really pushing my orbit out, and I'm going to go from a suborbital trajectory into an orbital trajectory very quickly at, less than half the cost than it would be just to burn where I was a minute ago. And anyways, so we're going to get to orbit really quickly. Once we're in orbit, we're just going to launch the satellite. You can see the other two satellites in orbit. They're just hanging out right now. Oh, and my camera changed. I did not change my angle that my craft was. And there we are, maneuvering the craft. I'm going to deploy my solar panels actually first. There we are, deploying the solar panels. I have it set so that both sets of solar panels deploy at the same time. And we're gonna, I think, launch. Yep, we're gonna activate the monopropellant on the small craft, so it's not just drifting helplessly. And this is amazing right here, how fast monopropellant works. So that's the big craft, it takes a lot of monopropellant to move it. But this craft is so little that it'll just zip away when I activate the monopropellant. See? Zipping away. Moves incredibly fast. It could actually move faster. It has more energy, I think. Well, no, my big craft has a lot of monopropellant, but small crafts can have tons of kinetic energy or potential energy, because they're just so small and light. And this is just a basic craft. And it's just going to go and sit in orbit and look down at the Earth, look down at everyone, spy on you. This is NSA, a spacecraft, I guess. Whatever. It all works out, and if I want to bring it back home, the parachute's there to ensure that it doesn't just crash. Most of the time they let them burn up, but I'm kind of a space recyclist. I think we should try to get as much back from space as possible. So that's the main reason why I include the monopropellant. I could have just left it floating there. It's a basic satellite that doesn't have any maneuvering capabilities, but I wanted to give it some capabilities. I actually think I could get it to the moon, and at this point I was going to think, should I try to get to the moon with this? Because I probably could. There's probably enough kinetic energy on it, or potential. I'm using potential energy is the amount of fuel I have. Now we're flying over a desert, and yes, it is flying. We are flying. Flying is just throwing yourself at the ground and missing. Alright, so now I'm gonna cut to the landing phase. I edited out the deorbit, and we're just gonna go straight to the landing phase, so see you in a minute. So I edited out the deorbit phase because it's just a generic deorbit phase. There's some atmospheric burning, the heating up of the underbelly of the craft. Nothing special. In fact, I can't remember, this was a while ago, but I think I actually do speed up enough to get those again, because we're in the high atmosphere right now. We're in we're about 1,500 meters, and the atmosphere again is thin, so we can accelerate pretty quickly. And so I have to keep my thrust down, otherwise we'll accelerate too quickly and we'll begin burning. I can't remember if I do that or not here. I know I did it on previous attempts. I should have kept the footage, but it was pretty funny because I did some flipping out. Yeah, it was interesting. And down there, where my mouse is, that was the first time I landed the aircraft. That's where I originally landed it. And I'm actually going to go to Kerbal Spaceport this time I actually did a good job at the deorbit burn and kind of getting a good deorbit burn that we don't deorbit too far from the continent, because we can go a long ways with the amount of fuel. I think we could even get to those islands that are just past the Kerbal Space Center and land on one of those islands if I kept my altitude, but I didn't keep my altitude. I kind of went down early and wasted a lot of fuel. And that's the key to high orbit flying, or high altitude, or high velocity flying, sorry, is you want to keep high altitude. The higher the altitude, the higher velocity you can travel at, so, and that's just the basics, and it's a pretty lackluster and boring. We get a great view up here, though, I will admit. I'm constantly trying to look around. The problem is I have to constantly keep my eye on the nav ball, and so if I look away for a moment, I get distracted, and high velocity hijinks ensues, and it's not good. So that's why I'm constantly looking forward. I'm not looking around. I know you guys would love for me to look around at the various areas of Kerbin rather than just looking straight, but you'll just have to deal with it. We're gonna pass over these mountains, and these mountains are quite famous for various test purposes, testing how spacecraft land on slopes and whatnot. They're pretty high mountains and they're pretty steep. I don't generally go to them. I don't really care for the mountains. I'm well versed with how to land things that if I land on a slope, I know generally. You don't want to land on a slope though when you're landing a spacecraft, like a capsule, like an Apollo capsule, like a lunar module. Because the problem is you have a likely chance of flipping over. But they're fun to explore, and I think there's an Easter egg here somewhere. Oh, and I'm pointing at the Kerbal spaceport right now. You can just see it barely over my aircraft, over the nose. Right there. As we get closer, we can more apparent what it is. Yeah, I think I could, like I mentioned earlier, I think I could reach those islands if I had kept my altitude up, but I didn't. So I waste a lot of fuel. Like I said earlier, the lower you are, the more fuel you're going to waste because you have the atmosphere pushing against you. The higher you are, the less fuel you're going to waste because you don't have to push as hard against the atmosphere. And actually, the higher you go, the less you have to thrust, add to your thrust. So you can actually save fuel and maintain speed. It's all really fun. And in a minute or so, demonstrate how to land this craft and why I chose those aerospike engines, those low profile. And just for your information, aerospike engines do exist. The reason why aerospike engines are so efficient is because you have the flame basically you have the flame or the heat source bouncing off that, or you have it concentrated on that air spike, and that air spike kind of gives it a mold for it to follow, and so you're actually pushing more efficiently, because the reason why rocket engines are inefficient is because the gas is expanded in the nozzle, and a lot of it is wasted heat that is wasted on the nozzle, but the aerospike engines work because most of that pressure and heat from the combining chemicals is concentrated on one little area, and that's why they're efficient. I don't really care for efficiency because I'm only using them in the high atmosphere. Aerospike engines are more useful at lower altitudes, but they're low profile. I need them for that reason. Otherwise, I'd have an incredibly long spacecraft. I'm using the RCS. You don't really need to use the RCS, but I'm just using it for more balance. And it looks cool. But RCS in the atmosphere isn't terribly efficient to use, and it's kind of a waste because the atmosphere is pushing against you. And coming in for our final approach, I'm not gonna nosedive, but I'm coming in at a steep angle, steeper than the shuttle would come at, I think. Normally the shuttle, when it's coming in, it would do these, I should make a video on this sometime, but it would do these odd maneuvers where it like turns, it does these turns, these weird aerodynamic turns to bleed off off excessive energy, because it actually has more than enough energy to get to the kinetic energy to get to the spaceport, or wherever they land at, either at the flats where they land at, or at Kennedy Space Center, or wherever they land. But with this jet engines, with the jet engines, you don't need to have excessive amounts of energy, and you can actually come up a little short if you want to, like we did. And we're just coming in for final approach now. As you see, I'm just trying to get my bearings. We're less than 600 meters, and I'm going to cut the engines, and I'm going to keep them on just a little bit, like give them a little bit of thrust so that we keep our batteries. I don't expect us to run out of batteries, but I also want to have the engines on just in case we need to take off again. I can just spool them up and they'll push us out of there, but I make it this time. Spoiler alert, I make it this time. And yeah, see, we have to land pretty much straight on, maybe a little bit of the back wheels arched down, but we have to land basically flat. And there we are. And that is how you land a single stage to orbit vehicle. Very simple. And we're gonna get Bill Kerman out of there. We're gonna park it first, and Bill Kerman's gonna get out and stand next to his aircraft for a pose. A pose of the man who went to space. Come on down, Bill. Anyways, hope you enjoyed the video. Hope it was informative in some way, and hope it helped you with some ideas to build an SSTO. See you around or something.